Hello, viewers. Yeah, it's me again, Mr. Mwangi Francis. Welcoming you to Elimu TV, your station where you watch and learn. So I'm taking you through chemistry form 4, where we are discussing radioactivity. Basically, in this lesson, we look at nuclear fission and nuclear fusion. Welcome. So what are the goals of this lesson? By the end of this lesson, my learned students and viewers, you'll be able to distinguish between nuclear fission and nuclear fusion. You'll also be able to write a balanced nuclear reaction. And also, you'll be able to state some of the uses of radioisotopes, that is, active materials. So what is nuclear fission? Nuclear fission is the splitting of unstable nuclide uh, as a result of bombardment. That is, it is bombarded by a fast moving neutron. This makes it to split, forming new nuclides of different composition, as well as there is a proton, one, two, or three, that may be produced as a result of this splitting of unstable nuclide. So how do we illustrate nuclear reaction, that is equation for the fission? We take an example of uranium 235. When it is bombarded by a fast moving neutron, it gives us two new nucleides, and we have three neutrons which are produced as illustrated from this equation. Do remember that the mass number on the reactant side must be equivalent to the mass number on the product side, and in addition to that, the atomic number, the number used as the subscript, must be equivalent on the reactant side and the product side. On the other hand, what is nuclear fusion? This is the linking of two unstable nucleides. That is, two large unstable nucleides. They are joined together. The joining of two unstable nucleides resulting into unstable, that is a new nucleide, with yielding of energy and particle. That is what we refer to as nuclear fusion. The diagram we have here illustrates deuterium and tritium, which are radioactive isotopes of hydrogen. When the two ring together, they form helium, a new nucleide, and there is a neutron which is produced, as well as energy. So how do we represent this in an equation, in a nuclear equation or reaction? So we have tritium, hydrogen isotope, and deuterium. The two, when they are fused together, ringed together, this gives us helium nucleide, which is a new stable atom, and there is production of neutron. Once again, the number of protons and neutrons, that is the mass number on the reactant side, must be equivalent to the number of mass number on the product side, and same does the atomic number, the subscript. It must be equal. That is, on the reactant side we have 1 plus 1, atomic number of hydrogen, giving us 2, which is the atomic number of helium. So what are some of the uses of these radioactive isotopes? One, they can be used in medicine, where they are used in the treatment of cancer. This may be used as well as in the treatment of breast cancer. The same thing used in medicine. In agriculture, they have been used in the control of pests, where there is male sterilization, which leads to production of unfertilized eggs, therefore limiting the population in a given ecosystem. We have also improved species of food production. This can increase the number of produce, or the quantity of produce we have in a country, and therefore helping us to fight hunger. There are some isotopes that can also be used in food preservation. So we have the application in agriculture. In addition to that, we have industrial application, where we have massive production of power in a nuclear plant. This leads to generation of power, and this power can be transmitted far away to consumers through pylons who use the power for other domestic purposes or economic purposes. Once again, in the field of medicine, they have been used in the sterilization of medical equipment, which was not done previously. So, did we get the concept of this lesson? Please, we can do that by answering these questions. This will help us to build that concept once again. Distinguish between nuclear fission and nuclear fusion. Complete the following nuclear reaction and list down 3 applications of radioactive isotopes. Stay tuned to Elimu TV. See you in the next lesson.